What's up, guys? Welcome back. We're going to look at the almost second to last penultimate section of this unit. The next unit doesn't have any questions that I'm going to give you on it, so this is really just like the last section of this unit. And what we're going to look at is sine and cosine. I have this unit circle here. You can easily do a Google search to find a unit circle, and you'll see all these benchmark coordinates and degrees, and the conversion is really cool because you can see what 30 degrees is in radian form and so on. And notice that it keeps increasing, right? Well, it starts off with 30, you add 15, you get that, you add 15, you get that. It's pretty cool. Okay, for y equal 5, 9 of x, its amplitude is, so this number is your amplitude, so you can see that's 5, and the period is, now here's the thing, this number over here, now if that was 1, then your period would just be 1, and what a period is, it's how many times it fits into a full revolution. If you want to think about 2 pi as being around the whole circle, right? Like if this was your coordinate plane, you start here, you went around and you came back, you ended here. That's 2 pi radians. So we want to know how many full curves, and this is what a sine curve looks like. A sine starts down here. How many of those fit into one full revolution? So that's 2 pi, and what's right in the middle? Pi, right? This is like 90 degrees, and this is this is 180 degrees, and this is 360 degrees. So halfway, which is pi over 2, that's really just 90 degrees. And over here we have 3 pi over 2, which is really just 270 degrees. Now this number tells you, well, it kind of tells you how many of them fits in there. So the formula is 2 pi, which is the full revolution, and you're dividing it by 9, and that's your answer. The period is 2 pi over 9. And let's type that in, and you'll see 2 pi divided by 9, and you get that number. Now remember, this video is meant to be quick, so I'm not really going into detail with it. I just kind of want you to be able to do the problems with it. So this is the formula. It's 2 pi over whatever that coefficient is, right? I'm going to put that in parentheses, whatever that number is. Okay, amplitude. So the amplitude is the height of the curve. If I go back to this picture, in this case, I would call that 5, and down here, -5, and like the height there is 5. That's what the amplitude is. So the same thing here. Even though you have that negative there, the height is 4. That negative does flip around the curve. Like we know that a cosine curve kind of looks like that, and the negative flips it around. So like it would actually look like that. So the amplitude is just that number. And what's the period? The period is 2 pi over a quarter. How many times could a quarter go into 2? Well, it could go into it 4 times. I'm sorry, 8 times. Right? 4 times every 1. I'm thinking dollars and cents. So the period is 8 pi. And if we multiply 8 times pi, you'll see that we get that decimal there. So even though the computer is like giving us a decimal thing, you want to have your answer like this, which of the following graph is a correct plot of y equal negative 3 cosine of x? So the negative flips the cosine curve, right? So I'm going to just draw a standard cosine thing here. So cosine starts off at 1, and I'm just going to draw the four benchmark points. This is pi, and that's 2 pi, right? And remember, this graph is really just the x coordinate of the curve. So it starts off here, and then it crosses at the 90-degree mark, which is pi over 2. And then it like turns right at that pi mark. And then this is your 3 pi over 2. Crosses back right there. And then over here comes back. Now, if you do look at that, if you do look at the unit circle, actually the video that's attached to this lesson is really good. I really suggest you look at it. Not my video, but the video on the website. It's really good. They use a computer to show you how this curve is created, and it's really cool. Definitely check that out. But okay, but this is your standard curve. Now, since the amplitude is 3, what that means is, well, I'm just going to call that 3 and negative 3, right? So if I was using some type of other technology, I would have taken this curve and stretch it a little bit, but you could just think of that as 3 and this is negative 3. But now this negative sign, it flips it around. So I'm going to do it in green. So it actually kind of goes the other way now. The height is at pi. Sorry, it still crosses at the same place and there. Alright, so it actually looks like that. And yeah, that's actually the graph. So let's see which one does that. So you see this one, the amplitude is 1. So we don't want that. We want this one over here. It's this choice. Which of the following graphs is the correct plot of that? So same thing. So we know, well, let me go back to red. So we know the sine curve starts at 0, 1, 2, 3, 4. And I don't have to name those to you. I'm just naming the middle, pi and 2 pi. And it reaches the height there, crosses there, it reaches the turning point and back. Right, and it just keeps repeating. That's a normal one. The negative is going to flip that around. So let's do that first of all. So it's going to go like this instead. The 2 makes the amplitude 2. So think about that, it's 2 negative 2. And that's that. So which one does that look like? It looks like this one. Alright, just making sure. Okay, and you see how it crosses at not exactly 3 but 3.14? That's pi. Okay, without graphing the function, determine its amplitude and period. Well, we know the amplitude is 2. And the period is just 2 pi divided by that number, which is just 2 into 2 is 1, 2 into 8 is 4. It's just 1/4 pi, or pi over 4, which is exactly what we have. Let me turn back to red. Without graphing the function, y equal 8 cosine of whatever, determine the amplitude and period. Well, you already know this is the amplitude. And the period is just 2 pi divided by negative 10. Now, whether if it's negative or positive, it doesn't matter. So you could like ignore that sign. And you just get 1 pi over 5, which is what we have there. Okay. Draw the following graph on the interval that. Alright, so now we have to graph. Just be careful when you're graphing these on the computer. You see how you have 2 types? One, like you select the middle point and then a high point or something like that. Just be really careful, because when I was doing it, you feel like you're getting it right, and then you use the wrong one and you're like, oh wait, it didn't do what it is I really wanted it to do. So just be really, really careful. And here's what I'm going to do. I like to just graph the normal thing first. So I know cosine is going to start at 1, right? So that's one of my points. And I know, well, let me draw this little thing first. So I know it looks like this, right? Now, this is my halfway point. And this is my full 2 pi. So remember, this is 180 degrees, that pi. And what about this point? That's halfway of that. This is pi over 2, which is really my 90 degrees. And I see I have a 90 degree there. So what I'm going to do is just like, it shouldn't have gone above that 1. So just to make the graph a little bit more accurate, just kind of like, yeah, this is this is not the best, but okay. And then well, if it does that, the other benchmark is 90 over here, right? So I mean, your computer will automatically do this part for you. Once you select this point and that point, it will automatically do the rest. But then the other benchmark point is 180, and since the amplitude is 1, at least with my standard thing right so far, it's going to reach that point. So that's all I'm going to do, and make it get to there. That's what it will look like from negative 180 to 90. Here's what we're going to do now. Well, let's do the 3 first. I think we could do negative 3. So the negative flips it. So instead of graphing that point there, I would have graphed it there. But since the amplitude is 3, I'm actually just going to make it there, right? And this point, since it's 0, it kind of just stays where it is. It still has to cross that 0 mark. This point too. And this point, since I had a negative 1, you have to flip it, but then the amplitude is still 3, so it has to go all the way up here to 3. So it would actually look like that. Cool. I hope I didn't confuse you with that one. Alright, show the following graph on that interval. Okay, so the amplitude here, you know what? Maybe I should graph some of these on the computer. I'll just do it here anyway. So y equal to sine of 2x. So we know the period is 2 pi over 2. So a whole curve fits into what half of a curve would actually be. So you know this entire curve, and it's sine, so it starts at 0 here. So you know that whole curve fits up until pi, right, which is 180, since they're using degrees here. All right, so let's see. I'm gonna continue this graph backwards, so it looks like that. Just finish it there. Okay, wait. I did this really not too nicely there, but whatever. You get the point. So this here is negative 180. So since they have it kind of backwards, I'm going to look at those benchmark points. This is negative 90. Thankfully, the amplitude is 1, so we could leave that alone. And it's not flipped around or anything like that. We could just leave this the way it is. And that's all you have to do, just plot those benchmark points. Just make sure and choose the correct one of those. I'm telling you, it will mess you up. Even though I'm telling you this, I know you'll make mistakes. That's not a problem, though. You can fix it. Okay, so let's see. The period is 2, so we're starting here. 90. The amplitude is still 1. So at 90, have to hit the halfway point. So right in between 90 is where the height would be. So right here, right, I'm looking at that distance, and I'm making sure that this is the midline, right? Like it's right in the middle. Let's erase that line as well. So I know it's gonna look like this. That. Nope. Nope. This is the middle. The middle is on 0. So it looks like this. And then if it has to end at 180, this is negative 120. Okay, so I'm looking, it's going by negative 15s. So this is negative 135, and then another negative 15 would be that. So negative 180. Okay, so this is negative 165. So negative 180 is like, it's like even further back. I'm not even going to draw that. So it's really important that you hit these benchmark points, at least when you're graphing it by hand. So what is in between 180 and 90? Well, I'm just going to do this. I went 1, 2, 3 spaces this way, 1, 2, 3 spaces that way, 1, 2. This is going to be my middle point. So that's where my graph is going to have that curve. And then remember, 180 is like somewhere there, so it's going to kind of go like that. All right, and since we want it between this interval, we're going to stop it right there. So that's what that graph would look like. But remember, I gave you quite a few points to choose from. All you have to do is just choose the 2 right points, and the computer would automatically graph the rest. Okay, don't be confused by this. All it did was it broke this up into all different types of stuff. Negative sign for this one confuse you. The period is simply 2 pi divided by a third. So that's the same as saying 2 pi divided by a third, which is the same as saying 2 pi times 3 over 1, which is just 6 pi. So what that means is that one curve happens within 6 pi. Alright, so let's kind of have a feel for that. This is sine. So sine looks like that. One full curve happens within 6 pi. So what's halfway in between that? 3 pi. So that means halfway in between that would be 3 pi over 2, right? Just divide that by half. So let's use those benchmark fractions. And well, let's convert it to degrees since we're using degrees. So what's 6 times 180? 6 times 180 is 1080. So a full curve happens in 1080 degrees. Then divided by 2, which is 540. So this is 540 degrees. And you can divide that one by 2. And you get 270. So this one here is 270 degrees. And let's just do this one here. So since from here to here is 270, you just have to keep adding on 270, right? So it's 540 plus 270. 540 plus 270 is 810. And then look at what happens if I add another 270. You get right back to 1080. So how much did I say that was? 540? Nope, 540 plus 810. So this is at 810 degrees. So we can use this information to kind of help us. We know that the amplitude is 1, and we know that the sine curve happens, it starts at 0. So let's see here. At 270, it reaches its height. So remember 270 this way, it will reach its height, right? Like, wherever 270 is. But 270 backwards, it will reach the height this way. So that's what I'm going to do. And then I know 3 pi is the next, 540 is the next benchmark. So it's going to come like that. And then a 10 is the next benchmark, so that it will reach its height there. And then at 1080, well, from here you could kind of leave it like this. It wanted it from negative 975 to that, right? If we had 1080, we would just kind of join it back on. So it'll be like, I don't know, something like that. To 225, 270, so it's going to be something like this. Like, it's not reaching the top there quite. So it looks like that. What is the amplitude of this function? Well, the amplitude is 1. What's the period of this function? 6 pi. Sketch a graph of this. Ooh, I'm really upset I didn't put any of these answers, just to, you know, double check, because one little tiny mistake and it will throw me off. Anyway, so we know that the amplitude is 1.5, but this negative sign is going to flip it around. But still, when you flip 0 around, it remains 0, so we know that's going to be a starting point. And 2 pi over this number, the period is pi. So within an entire curve, one entire curve fits in pi radians. So let's graph this. Let's see what's here then. So then this is pi over 2. Hopefully we could kind of just use these to figure it out. So at pi over 2 is the middle. And then at pi, which is, you know, see how to split it up here? 7 pi over, at 8 pi over 8, which is just pi, that's when it reaches its full curve. So that means right in the middle of this, and which one is the middle here? I would say right here. The amplitude is 1.5, so it would have been here, but since it's getting negated, it's getting flipped around, it's not going to be right there. It's going to be down here instead. And then this one is going to end up, where's the middle between those 2 points? Right here. Notice I'm going to notice that I'm going to 1.5, right? Because that's the amplitude. That's the height. And then you can kind of just figure it out backwards as well. Alright, which I'm not going to do. I'm just going to leave this like that. Well, I feel bad. Let's just do it. So notice that every 2 spaces, you're going to have a key point. So 1, 2 right here. 1, 2, 1, 2, 1, 2. So it'll reach a site here. It's going to cross right there. It'll reach a minimum there, and then it'll cross right there. Amplitude is 3. The midline, okay, so the bottom line is that's going to be the midline, y equal whatever that number is. But if you think about it, right, cosine, I'm just going to draw the cosine curve because that's the function we're talking about here. But the midline is, for any of the basic functions we have, is y equals 0. It's the x-axis. The y value is always 0. Now this is shifting it upwards 9 units. So if I were to shift the midline up 9 units, it will just be y equal 9. So that's why it's always that number. Okay, given the equation that the amplitude, so the amplitude is 7, the period is still that number. Notice that it's in factored form. You need that x by itself. So the period is 4. The horizontal shift, okay, this number in here tells us the horizontal shift, and this one tells us the vertical shift. Vertical shift is up and down, and the horizontal shift is left and right. No, you always have to do the opposite of whatever that sign says. So it is 8 to the left. Right, so the horizontal shift is 8, and the answer you select there is left. The midline is y equal 3. Given that equation, the amplitude is 3. Let's factor this. Do we even have to factor it? I think yes. Yes, we do. So factor out that 8. And we get x plus 6. Right? So just picture this as the thing that's really in there. Let me just see something. Did I make a mistake before? Yes, the period is not 4. Nobody corrected me. What's going on here? The period is 2 pi over 4. 2 and 2 is 1. 2 and 4 is 2. So the period is actually pi over 2. So it's the same thing here. This is 2 pi over 8. And that works out to pi over 4. The horizontal shift is this number, but remember you do whatever the opposite of that sign, so it is 6, not to the right, but to the left. And the midline is y equal 2. Okay, find a function of the form that, or that, whose graph is its function below. Now, which of those functions, start at 0? It's going to be sine. Let's see what the amplitude is. Right, the amplitude is 2. You go 2 up and you go 2 below. So the amplitude is 2. And let's see what the period is. Now I'm looking at the left side of this. An entire period happens within 10 units. So if a period happens in 10 units, 2 pi divided by 10 is simply pi over 5. So the number that goes right here is pi over 5. I'm sorry. Pi over 5x. And that's your answer. That's all the information from there. Notice that to find the period, if you went backwards, you could easily do this check. 2 pi divided by pi over 5, that's really just 2 pi times 5 over pi, right, times the reciprocal. These cancel and you get 5 times 2 is 10. So you actually get that period back. You could always do that and check it. Just want to label this check. Okay, same thing for this one. So let's see, starts at 1, so we know that this is going to be a cosine, and 1 full period happens. I'm going to look at this side again. 1 full period happens right up to there. It happens at 14 units. So it's going to be cosine of 2 pi over 14. 2 into 2 is 1, 2 into 14 is 7. So pi over 7x. Doesn't seem to have a horizontal shift, a vertical shift, and also the amplitude is just 1. So that's your final answer. And we can see that it's right there too. Find a function of the form that. Okay, so same type of question again. Now let's see, this looks like a sine curve, so because it's starting at 0. So let's do that. Sine. The amplitude is 4, right? Because the height of this thing, all of that distance is 4. So let's put a 4 right there. And I'm looking for 1 period of this, and that stops right there as well at 14. So 2 pi divided by 14 is pi over 7, just like the last question. Pi over 7. Any horizontal shift or vertical shift? No. So we could leave our answer just like this. Should really be writing y equal in front of there, but okay, same thing here. This one was definitely shifted down. So imagine this starting at imagine you shift this whole function up 1, and that means this point would have been right here, right? And which function starts off at 1? Cosine. So I'm looking at the midline, right? I want to make the midline the y-axis. So that's how you could tell that the shift was 1. So to do that, I have to picture the original function shifted down 1. That means that this number out here will be -1. The amplitude is 1, so we could leave the number here as just 1. And let's see how long it takes. So 1 period. I'm looking at this side, and it's 6 units. So that's 2 pi over 6, which is just a third pi. So I'm just going to put pi over 3x. And I don't see any horizontal shifts. So this is our answer. And it is the same thing as down there. Same thing here. Now I'm looking at that midline, and I wanted to match up this, so I had to shift it up 2. So the first thing I know is that I have to think about the original function, and I'm minusing 2 at the end. And it starts at 0, so that will be a sine. And the amplitude is, ooh, that looks like 1.5, right? It doesn't quite make it to 2, but it's over 1. So let's say 1.5. So that's the amplitude. And let's see what the period looks like. Period is 1 full curve. So it stops right there. That's also 14. So that's the same thing as pi over 7. Don't see any shifts in any other direction. So that's that. Second to last question. Oh, this one I put an answer key. I don't know why. But oh, okay. Take care of this, right? That flips it around. Ooh. Horizontal shift to the left of that much. Okay, so here's what I'm going to do. I'm going to draw my standard function, the amplitude. The amplitude is 1, and the period is 1, so that's helpful. So really, we want to think about the standard function just shifted and flipped around because of that negative. So instead of me going, well, remember, I'm going to just highlight my key points here. Okay, so instead of me going up there and then down through there and then down through that, what I'm going to do is flip that around because of this, because of that negative sign. So I'm going to go down. Oh, I actually went up too high there. I had to go down 1, then through there, and then through that way. So I'm going to erase this. Now, the reason I'm not drawing the whole thing is because I still have to shift it. What I'm going to do is shift it to the left first, right? 3 pi over 4 units. So that means this point really moves over there. And then, okay, let me do this in green because that's confusing me. Right, this point gets shifted there. So what about this point? The point that's 2 spaces away. It gets shifted right here. And then another 2 spaces is my key point. Another 2 spaces is my key point. Another 2 spaces. and I'm going to go backwards 2 spaces. Right. So let's just erase that line. Let's erase that line, and this was originally red, so let's put that back red. So it's like we're starting here, and at that point it turns, then has to go through here, and then it turns at that point, then it goes through there, and well, it kind of goes that way. Same thing here, so it comes to a turning point there, and then it's going to go down that way. Let's erase. I'm going to erase this just to not confuse me. Now I'm going to erase these points too, because we don't need them. Now let's do the final shift. You got to shift it up 1, so everything has to be shifted up. I'm going to do this in blue. So this point gets shifted up 1 space. This point gets shifted up exactly 1. Ooh, you see, I went too high here. This should have been like that. And this too should have been like that. Okay, so this point gets shifted up 1 full unit, which ends up right there. This point, hold on, I'm missing a key point, which is this one. This one gets shifted up 1 whole unit, 1 whole unit. You get the point. This one gets shifted up 1 whole unit. This one, 1 whole unit. All the points get shifted up 1 whole unit. Now let's see what that looks like. I will do this one in, well, I'll go back to red. Yeah, I went up too high. That should have been right there. Alright, it's like going off in that direction. Since this is turning, it's going off in that direction. So look at the red line. Again, this was not that pretty on paper, but when you do it on the graphing, when you do it on the computer, it should be fine. And you should see at pi over 4, I have it crossing at the right place. I'm just going to check a few places. This is crossing at 2. This one is crossing at up there. When I said 2, I was counting 2 spaces. And yeah, so that's how you do this. Alright, graph the original, and you can actually do that on the computer. You could graph the original and then move the points. Last but not least. Okay. Alright. Flipped. Amplitude is 4. Period. 2 pi over pi divided by 4, which is like saying 2 pi multiplied by 4 over pi, which is just 8. Alright, so you have a whole curve, and it's a sine curve, so it looks like a whole curve happens at 8, midpoint is at 4, and thankfully there's no shifting left or right, so that's going to help us a lot. But everything gets shifted up 1 because this is our vertical shift. So let's do that. So instead of starting at 0, I'm going to start at 1 because it got shifted up 1. And the amplitude is 4, but I know that it got flipped, right? So instead of going like this, I'm actually going to go down, but I know that the midpoint is at 4, Oh, I forgot I have to shift it up 1. And then my midpoint is at 4. And then my ending point is at 8, right? So the in-between points are my heights, my max and my mids. But I know it's getting flipped, and I know that the amplitude is 4. Okay, so 1, 2, 3, 4. This is where I'm gonna connect this to, like that. It needs to be really smooth. My curves are not nice because they need to be a lot smoother than that. And then for this one, I'm just gonna go right up past it, and then 1, 2, 3, 4 right there is gonna turn, and then it's gonna come right back there. All right, and I'm just gonna check that half of the graph so you can see. All right, I'm gonna check this is the point 2, -3. This is the point 2, -3. 0, 1, 0, 1. 4, 1, 4, 1. 6, 5, 6, 5. And you could just do it going backwards as well. And again, just know a few key points. Once you know your key points, you're good. And that's it. I'll catch you on the next one, guys. Bye.